All right, let's talk about a number we all think we know, pi. It feels like this fundamental constant of the universe, right? But what if I told you its real origin story is way, way deeper than anything you learned in geometry class? You know, we all memorized 3.14, that endless, kind of magical string of digits. But there's this really fascinating framework called Ontological Hierarchical Emergence, or OJE for short, and it suggests that pi's real story, well, it has almost nothing to do with circles at all.
I mean, this is what they teach us, right? It's the ratio of a circle's circumference to its diameter. Super simple. You draw a circle, measure it, and boom, there's pi. But what if that's looking at it completely backwards?
And this quote really nails the OJ's whole point. It says that defining pi with a circle is, well, it's a circular argument. Think about it. If things like space and geometry are properties that emerge from something more fundamental, then the rules that create them have to come first. So pi must come from something deeper, something that exists before you can even draw a circle. So to really get to the bottom of this, we have to talk about the most fundamental rule of reality in this framework. It's called the finite ontological budget. Just think of it as the ultimate conservation law for existence itself. The idea is pretty wild. Basically, existence isn't free. It has a cost. It's kind of like a video game character, you know? You only have so many skill points to spend. Well, every single system, from a tiny particle to a whole galaxy, has a finite existence budget, which OJ calls K. And that budget has to be managed. And this is the master equation that runs the whole show. U squared plus V squared equals K squared. Now that should definitely ring a bell. It's basically the Pythagorean theorem, right? But here, it's a conservation law for reality. The total budget, K, is always conserved. And those squared terms, they're not just there for fun. They're a huge clue about the deep geometric nature of how this all works. So that leads to this universal trade-off. The budget is always split between two things. You've got U, which is all about being, what a thing is. Think of its identity, its mass. Then you've got V, which is about doing, what a thing does, its motion, how it interacts with other things. It's a constant cosmic balancing act. If you put more energy into being, you have less for doing, and vice versa.
Okay, so let's pause here, because this brings up a massive question. If the total budget is fixed, how can anything happen? How can anything change? Logically, it seems like the whole universe should just be frozen in place.
Right? I mean, if K can't go up or down, then any change should break that master equation. But obviously, we look around and see a universe that's incredibly dynamic. Things are constantly happening. So how? What's the secret sauce? And the answer is surprisingly elegant. The only way to reallocate the budget between being and doing without breaking the K limit is through rotation. Picture it. The system state is just moving along the edge of a circle. The balance between U and V is constantly shifting, but the radius of that circle, the total budget, K, it stays perfectly, totally constant. And here's the thing. This isn't just a nice little metaphor. In the actual math they use to describe all this, it's called space-time algebra. This is a hard and fast rule. For a finite system to change without breaking its own rules, that change has to be a rotation. There's no other way. Okay, so this whole idea that change must be rotation, that's the absolute key, because it leads us straight to our mystery number. This is where we unlock the whole puzzle.
Think about it. If all change in our finite universe is, at its core, rotational, then the one number, the one constant that defines rotation, has to be baked into the very fabric of reality itself. And what is that constant? Of course, it's pi. So there it is. That's the big reveal. Pi isn't about circles you draw on paper. In this framework, pi is the mathematical signature of a universe with a finite budget. It's the magic ingredient that lets a universe with a fixed, closed capacity still have open, infinite possibilities for change inside of it.
You can almost think of pi as a kind of universal guarantee. It's the parameter in the system's programming that makes sure the cycle of change, that rotation from being to doing and back, always closes perfectly. It ensures the universe doesn't break its own rules and just fall apart.
Okay, so if this is true, if pi isn't just some weird number we find in circles, but a fundamental parameter of existence, well, the implications are just huge. This changes everything about how we look at physics.
I mean, this reframes some of the most mind-bending concepts out there. Suddenly, the imaginary number I isn't imaginary anymore. It becomes the actual tool, the operator, for these fundamental rotations. The basic atom of reality isn't just 1 for existence, it's 1 plus I, existence plus the built-in potential to change. And all of a sudden, laws of physics just pop out as necessary consequences of managing this cosmic budget. It even flips the whole it from bit idea on its head, suggesting that being has to come before information.
So, the takeaway is, we've had it completely backward this whole time. We don't find pi and circles, we see circles because the universe is built on this fundamental, rotational logic, a logic that has pi hardwired into it from the very beginning. The circle isn't the source of pi, it's just an echo of it.
It's just such a powerful shift in perspective, isn't it? Taking this number we thought we understood and seeing it as a cornerstone of existence itself. And it leaves us with this one final, really mind-bending question. If pi is the constant for a finite reality, then what are the rules that govern the infinite?